Okay, so good morning once again. It's rather unfortunate that our last video or the last class I couldn't complete it, but I think within those I will be able to do that for you. Yeah, so let me try and share my screen. Yeah, there we go. So, and there's one thing I think when I was trying to choose a component. This thing was actually worrying me there. Okay, so let's try and design our circuits once more. So I tried to pick, I'm just trying to check if I'm online. Okay, we pick our component from here. So what the symbol very well, you see it like a battery. When you click there, most of the components can be gotten from there. Good. So we need DC power. We have AC power. That one is around like this. And I don't think we'll be tackling AC for your class. We will tackle only DC. So we have DC here. DC power is just a battery. Then I pick it. When I click here, it shall be dropped there. Then the next thing is a switch. But if I need a switch, I have to come back to the source, click on source. After clicking on source, I go to basic because switch is under basics. Then I have my switch there. So I can just use the first switch. The switches, we have different types, but I want the first one. So I pick it, then I drop it there. Then the next thing that I will deal with is a load or maybe a lamp as we did. So I go back to this side. Then under indicators that I'll get a lamp. So the lamp is also there. So if I pick 12 volts, 25 watts, I'll have it there. But then I told you that always when you are designing, try and always add a ground. I'll tell you why we add ground another time. Actually, it is the nature of this kind of software. But then let me give you some, well, let's move together because it's like I was trying to rush. So when I click here, you see that a particular line will be following my cursor. Then when I come and click back here, it turns red, meaning it has been connected. I do this, but then this one too, I don't like the way it's laid. I want it to be vertical. So let me press escape, then the light goes away. I click on the lamp, then I press Control R. Control R means it shall be rotated. Control R. See that it has been rotated? Yes. I want it to be this way so that the connection will look nice. So I click this way, click here, click this way. Now our circuit is complete. So I think I did a demonstration whereby we tried to change this battery. So when I start my simulator, I can either start it from top here. We have 0, 1. I can go to 1 for it to be simulated. Or there is a symbol here, which is a play button. I can also use that one. And when I press my key, I have my light. Simple. Now, there is something I want us to do. Let's check the amount of current that is flowing to the circuits. So let me click on this one and push it back small. I just want this space to fix my instrument. And I don't know, we started these kind of electrical quantities, and I was talking of current. And I said, if I want to measure current, the instrument that we are supposed to use is an ammeter. And you remember. So if I want an ammeter, I go back to where I pick my components, go to source, then I go to indicators. Within that place, I'll see ammeter there. If I pick the horizontal ammeter, it means I can slot it this way. But if I had wanted to slot it in the right-hand side, for it to be vertical, then I would have chosen the vertical version. So this one, when you just click on the line like this, it shall just be fixed. So let me close it. It is fixed for me. So let's expand our screen small. Right. So now let me try and simulate again. Now start the whole simulation. The ammeter is recording 0. And who knows why it is recording 0? It's recording 0 because no current is passing through this line. Why? Because the switch here is open. If you don't close the switch, no current will move. But when I close the switch like this, the lamp comes, then the current is reading 2.083 amperes. 2.083 amperes. When I take the switch back off, I'll see that it goes back to 0. Okay. Our next instrument is a voltmeter. What is the meaning of voltmeter? That one is used to measure the voltage across a component. You see, we have this 12 volts lamp, but let's see whether we are actually getting 12 volts around it. We are feeding in 12 volts, and it is the only load in the circuit. And we are assuming that it is the only guy that will be taking all these 12 volts. So let's measure the voltage across it. So I'm going to put the voltmeter across here. So because I'm putting it on my right-hand side here, I should use the vertical version, not the horizontal version like I did for the ammeter. Right. So I go back to this, look for indicators. Sorry, look for indicators. I go to voltmeter. But the voltmeter, the vertical one has already been picked. So I pick the vertical one. I bring it to the side, close this, then I join the probes. So after this, I can now simulate. And still, we are reading 0, 0 because the circuit is what? Open. So when I close the switch, the circuit is now closed and you see that it is what? 12 volts. 12 volts because it is the only component that is what? Taking this 12 volts from the source. The switch and the instruments, none of them consume any power. When you connect them, they don't consume any power. So I'm going to increase the circuits a bit. I'm going to do some few modifications so that we see what happens. So let's take it off. Take this one too off. What I want to do now is that, assuming you have 3 rooms in your house, and each of them is having one bulb. You and your 2 brothers. This one is here. So this one, if I want to get a copy of it, or I'll just say, or I had wanted to change the values. Yes, let me use different lamps. Though in our rooms, we don't normally use the same lamp type. So let me go in there and go to indicators. Then I take a lamp. This time around, I'm using 12 volts, 10 watts. Then I fix this one. Then maybe I go for 30 volts, 10 watts. Different types of lamps. So let's do our control R. This one too, we do our control R. Then we try to connect them all. So we have one source, which is going to feed this, feed this, feed this. So let's see how the circuit will look like. So right now you see that we are having 3 lamps. This one need 12 volts. This one need 12 volts, but remember this one need 30 volts. So let's see whether the 12 volts will be able to power all of them. I hope you are getting it. So let's simulate. And when I simulate and put on my switch, you see that these 2 lamps come, but this one will what? Will not be able to come. So what do we do? Should we increase this? or we reduce this because the voltage needed, we can't get it for you. The whole house has 12 volts, but you have got a 30 volts lamp. So it's possible we can't feed you there. But then let's try to increase this voltage to the 30 as we want. Then we see what will happen. So this is now 30. So let's simulate and see. First of all, I put it on, then I close the switch. Now we've been able to feed this lamp. It has come all right. But when you look at the two lamps over here, we've destroyed those lamps. Why? Because they don't fit. So as an IT person, you have to be smart all the time. Or as an electronic student or person, what you should do is to go back to the market and change this lamp. That's the best way that will help you. So that we keep this our 12 volts. Sorry. We keep this 12 volts. Then we go back there, right click on it, then you go to replace component. It will send you back to the lamps. Then maybe we can pick any of the 12 volts lamps. Then we put it there. So at the end of the day, when I start my simulator and close those, all my lamps are on now. But are they all taking the same voltage? Yes, because we have 12 volts, 12 volts, 12. But let's see their current. The current will be different because they are using different wattages. If you look at the watts or the power, this one is 25 watts, this one is 10 watts, and this one is also 25 watts. So let's check the current in them. If I get the current, I can multiply the current by the voltage and get the power. But then first of all, let's check the current. What type of ammeter will I use? I wouldn't use the horizontal one because I'm not placing it this way horizontally. I'm putting it vertically, so I'll bring it here. So let's look for this. I always want to make sure that I am audible because it's not an interactive video. Fine, so we go back to our indicators, look for my ammeter, but this time around I'll pick the vertical one. Slot this one here for this lamp, slot this one here for this lamp, then slot this one here for this lamp. So we are done. Let's now simulate and see. Simulate it, put in this, everything start flowing. But you can imagine, this is 25 watts. It is taking 2.083 amperes. So this one is the same 25 watt, is taking the same current as this. But this one is rather taking what? 0.833. So it tells you that the one with the lower power is the one that will get the highest current. That is it. So when we come to class and we are doing our calculations, you see it, you see the way or the reason why it is so. So that is it for now. Let me demonstrate a resistor for you to see. So let's take off this lamp, take off this lamp, and take off what? This lamp. So let's take this one to off. I'll just click and press delete. You'll go. So let's bring in a resistor. If I want a resistor, I can just get it here. You click here, you go to basic, and the basic you go down. Resistor is there. Then I pick the resistor. What did we see a resistor is? We see that it opposes the flow of current. So this one to control R, then I'll change the orientation. Now let me change the value to maybe 2. And we all remember the calculations that we did. If I have voltage and I have resistance, how do I get current? We just divide voltage by resistance and we get current. So let's measure and see, or let's first of all do our calculations. 12 divided by 2 will give us 6 amperes. So let's try and bring in an instrument that will measure the current for us. And we all know it is an ammeter. So let's try and bring in our ammeter. Go for indicators, take the ammeter, but I need the horizontal one because I want to place it up here. So after everything, we simulate. For simulating, I close the switch, current move towards our resistor, and the value there becomes 6 amperes. As simple as that. So that is it for now. When I continue increasing this resistance, let's see what will happen to the current, because we see it is inversely proportional because it's always dividing. So let me double click. If I want to change this value, I double click on it. Then I type maybe 4 ohms instead of 2 ohms. I've increased the resistance. Let's see the current. So when I simulate and I put in the switch, everything becomes 3. It has reduced from 6 to 3 because we are now dividing 12 by what? 4. As simple as that. So that is it. I will upload this uh, for you to watch. When I come to class, there are a lot of calculations that we are going to do around those simulation aspects. Thank you. Okay.